In our last lecture, we looked at how the city of Philadelphia coped with the deadly second wave of the 1918 flu. In our final lecture on the flu, we'll see how the lingering effects of the flu helped set the stage for World War II. And we'll follow modern medical detectives as they race to recover the virus and learn its secrets. As the end of World War I approached, rumors of armistice began to fly. But President Woodrow Wilson was determined to fight to the death and concede nothing to the aggressors. Wilson proclaimed that, "To fight, you must be brutal and ruthless. Force to the utmost, force without stint or limit, the righteous and triumphant force that will make right the law of the world and cast every selfish dominion down in the dust." President Wilson met with Lloyd George and Clemenceau in Paris in early 1919 to work out the terms of surrender. The third wave of the flu was just hitting Paris at that time, with flu-related deaths back up to 2,676 in February, and one of those victims was Wilson's daughter. One of Wilson's aides writes, "There seems to be millions of throat germs going around, and a number of diplomats have lost their voices altogether. The old world is badly germ-ridden. It is soaked with disease." On Thursday, April 3rd, Wilson was struck by a coughing spell so severe he had difficulty breathing, and the attack was so sudden that Dr. Cary Grayson, Wilson's White House physician, at first thought that Wilson had been poisoned. He was very ill, severe diarrhea, had a fever over 103 degrees. He lay in bed for several days, couldn't even sit up until the fourth day. George and Clemenceau came to Wilson's room to continue the talks, but the talks went very poorly. Wilson was gaunt and haggard, had a pale face and sunken eyes, but he continued to drive himself relentlessly. Herbert Hoover grew concerned that Wilson had changed after his illness, becoming stubborn, unwilling to listen to advice. Secret Service agent Colonel Starling noted that Wilson, quote, lacked his old quickness of grasp and tired easily. Wilson became paranoid, insisting that his home was filled with French spies. He grew obsessed with the most trivial details, like who was using what official vehicle. Lloyd George refers to Wilson's nervous and spiritual breakdown in the middle of the conference, attributing it to overwork and harsh criticism by the press. And Gilbert Close, Wilson's secretary, writes, "I never knew the president to be in as difficult a frame of mind as he is now. Even while lying in bed, he manifested peculiarities." And then Wilson suddenly announced a complete change of face, conceding to Clemenceau virtually every point that he had previously fought so hard to make. Later authorities speculated that Wilson had suffered a mild stroke, ignoring his bout of flu, and that stroke is an idea that persists to this day. And for good reason. We don't normally associate flu with neurological or psychological problems. But the 1918 flu, that was the exception to the general rule. It left many of its victims with permanent mental damage. Dr. Charles W. Burr, a specialist in mental complications from influenza, wrote back in 1918 that the typical flu survivor might face some long-term mental problems. Quote, "To make a decision about some trifling matter tires him, and an important matter requiring any deep thought for even a short time must be put to one side." So, did Wilson's concessions result from his struggle with influenza? A careful examination of his state of mind before and after the flu strongly suggests that his illness changed his attitude and behavior profoundly. Whatever the cause, by caving in to Clemenceau's harsh treatment of Germany, Wilson helped to create the conditions that ultimately led to the next World War. Adolph Burl Jr., later to be appointed Assistant Secretary of State, says in his letter of resignation to Wilson, "I'm sorry that you did not fight our fight to the finish, and that you had so little faith in the millions of men like myself in every nation who had faith in you. Our government has consented now to deliver the suffering peoples of the world to new oppressions, subjections, and dismemberments, a new century of war." Well, between adding to the miseries of the First World War and contributing to the rise of the Second World War, the 1918 flu had a big impact on human history. What if it were to return today? Would we be prepared to fight it? One of the most fascinating aspects of the 1918 flu turns out to be a detective story, the search in modern times for an intact virus. And that search is no idle exercise because, in the wrong hands, the virus could make a formidable weapon. But if we can find one, maybe we can figure out why it was so incredibly deadly. And if we can decode its genes, we might find a way to fight it or any similar virus. We're more vulnerable today than our parents were in so many ways. We've made all of these great advancements in public health and medical technology, but recent changes in lifestyle and diet have left us a lot closer to the brink should that deadly flu be unleashed in our lifetime. Think about how quickly the 1918 flu was spread by rail and ocean liner. Our modern network of interstate highways and global airlines would disperse a killer like that a lot faster and more effectively. And our increasingly interconnected global trade system is also more easily disrupted. We're less self-reliant, economically speaking. So a global pandemic might trigger a cascade of economic collapse, leading to shortages of critical items. And our growing reliance on refrigerated and frozen food means that our homes contain a significantly greater amount of perishable items. Remember how Philadelphia's stores closed down as the flu began to spread? With a minimum of canned goods and dry food in our pantries, most of us would soon run out. Go back to 1957, a typical American family ate about 90% of their meals at home. Their kitchen contained only about 20% perishable foods, mostly different kinds of fresh fruits and vegetables. The modern American household eats at home only 62% of the time, and 48% of the food in the typical home consists of perishable food. Let's face it, if McDonald's and Burger King were to close tomorrow, a significant portion of my immediate family would probably starve to death within a month. So being more vulnerable means we have to be better prepared. And that preparation starts with a better understanding of what made this flu virus so dangerous. But where to begin? Few samples were preserved at the time. People didn't really know what viruses were, much less how to save them. So how to find a sample of the deadly virus? Well, the answer is simple. Look in the lungs of the dead. The U.S. Army had preserved many samples of lung tissue from dead soldiers, soaking them in formaldehyde and encasing them in little squares of paraffin. In fact, the original orders to preserve tissues from diseased military personnel came from none other than Abraham Lincoln. Jeffrey Taubenberger of the Armed Forces Institute of Pathology, along with his colleague Ann Reed, began trying to isolate the virus from a scrap of lung tissue that they took from a young soldier. Meanwhile, Dr. Kirsty Duncan, anthropologist, geographer, amateur virologist, had become obsessed with solving the mystery. And she reasoned that only burial in permafrost would have saved that 1918 virus that long. A 4-year search led her in 1997 to a little frozen cemetery in Spitsbergen, a tiny windswept isle some 600 miles north of northern Norway. And there had been several coal mines on the island active in the early 1900s, operated by the Arctic Coal Company. Now, Duncan knew that the flu had hit Norway, and she wondered if any miners had carried it to Spitsbergen. She finally narrowed her search to the mining town of Longyearbyen, which was a seasonal mining town. You fished in the spring, you mined for coal in the winter. Most of the local records had been destroyed in World War I, but she finally managed to track down some old company diaries held by a local school teacher. And using those diaries, she found a cemetery with 6 young miners from Norway who had died of the flu just after leaving the ship and were buried in the frozen soil. As she was assembling an expedition to exhume the bodies, Taubenberger was closing in on the prize. He contacted Duncan, and the two of them actually collaborated for a while, but they very soon parted company. Duncan found Taubenberger and Reed to be too cautious, too methodical, and Taubenberger found Duncan to be much too flamboyant. Duncan's expedition prepared to don moon suits to prevent the release of live virus, but that elaborate exhumation proved a complete bust. The bodies turned out to be buried too close to the surface and were badly decayed. keep an eye out for reruns of Virus, a 1995 NBC TV movie which is based on a Robin Cook novel and features a fictional Kirsty Duncan type racing to unearth the 1918 bug in order to fight a modern epidemic. Meanwhile, Taubenberger had been contacted by a retired pathologist named Dr. Johann Hulten. And Hulten had actually beaten Duncan and Taubenberger to the punch by almost 50 years. As a young graduate student in 1949, he had also become intrigued by that elusive 1918 virus and became determined to find it. In fact, he decided to make the virus the subject of his dissertation. He tracked down a mass grave of 72 flu victims in Brevig Mission, Alaska in 1951. But the expedition was a failure. He found several bodies, but he was unable to recover any of the virus. 46 years later, 1997, he read an article in Science by Taubenberger and decided to try digging at Brevig once again. So while the world was watching Kirsty Duncan, Dr. Hulten flew back to Brevig, checked into a local motel, and began digging for new samples with his pickaxe. Most of the bodies that he found were very badly decayed, but there was one obese victim, dubbed Lucy, who was fairly well preserved. Heavy layers of fat around her lungs had protected them, and Hulten was able to collect several tissue samples. He sent the infected frozen samples to the Army Pathology Lab through UPS, the U.S. Post Office, and FedEx. Those were the days. Well, this time Hulten was successful, and Lucy yielded several viral fragments. Taubenberger used these samples, together with the Army samples that he had collected, to sequence several of the viral genes. Although we solved one mystery, finding intact genes from the 1918 virus, several mysteries remain unsolved. Why did the flu kill so many young adults? Why were the 3 waves of flu so closely spaced? And where did it come from? To this day, no one knows why the flu hit young adults so heavily, producing that W-shaped curve we talked about rather than the usual U-shaped curve of mortality. So instead of that normal decline in deaths in young adult and early adult stages, the 15 to 34 age groups in the 1918 flu show a big spike of mortality. Well, it may be that the healthy immune systems of those young men and women were their undoing. And that's a novel concept. Can there be such a thing as being too healthy? Remember that the sheer devastation of the lungs of soldiers was comparable to the damage done by mustard gas. Some doctors think this damage was partly due to a deadly overreaction by the immune system, what we call a cytokine storm. Maybe the cytokine storm was particularly intense in those that had the healthiest immune systems. Or perhaps young adults in 1918 had especially high levels of tuberculosis, leaving their damaged lungs ripe for invasion by influenza. The unbridled virulence of the flu probably contributed to its ultimate undoing. Flu is driven by herd immunity. It needs to constantly hop from one population to the next as each host population either dies or acquires resistance. So we would expect to see waves of flu spaced several months apart. Major antigenic shifts would be required every 2 or 3 years to survive herd immunity. But the 3 waves of the 1918 flu were very close together. Each wave should have been months apart, but in some areas, the 3 waves of the flu were only weeks apart. And in a few places, the waves were so close together, it's hard to say where one ended and the next one began. In the Northern Hemisphere, the first wave lasted from spring into summer, the second wave from summer to fall, and the third wave from fall to winter. And that tight spacing remains a mystery to this day. It lends some support to the argument that that second wave was a hybrid virus or a mutant strain, because a hybrid or mutated flu would be sufficiently different to overcome the partial immunity of survivors of the first wave. Cycles of the 1918 flu are so out of step that many scientists have come to doubt the validity of the whole idea of epidemiological cycles, at least where the flu is concerned. Maybe the patterns formed by the hypermutable virus are just too unpredictable. Or perhaps we're missing a much larger pattern. One hypothesis suggests that H1, H2, and H3 flu strains are macrocycling, competing with one another in cycles that can last 68 years or more. There are three genera of flu: type A, type B, and type C. Type A is the most dangerous. It infects humans and other mammals, including pigs and birds. Type B infects humans and seals. Feel sorry for the little guys. And type C infects humans and pigs. Each type can have many subtypes, and each subtype can have several variants. Remember those H spikes and N spikes on the flu virus that we learned about in Lecture 11? Well, there are 16 known subtypes of the H antigen and 9 known subtypes of the N antigen. Flus prior to 1957 are designated subtype H1N1, so the 1918 flu was H1N1. The 1957 pandemic was caused by a new subtype, H2N2, which left 2 million people dead. The 1968 Hong Kong flu was H3N2, and it left 1 million dead in its wake. We think that both the H2N2 and H3N2 subtypes are a mixture of bird and pig flu genes. The molecular evidence suggests that the 1918 flu was H1N1, a novel strain of bird flu which later spread to swine and humans. Now, there are no known records of epidemics among poultry at that time, but ironically, bird flus are usually asymptomatic for birds. They carry it, but they don't suffer from it. In the wild, we think ducks are the natural reservoir, and we've taken samples of avian flu from preserved wild birds in museum collections, and they turn out to be very similar to the ones we collect today. But the 1918 flu, well, that's a different kind of avian flu. Remember our earlier discussion of competitive exclusion? Flu is rather unusual in that new subtypes of flu tend to drive all of the old subtypes into extinction. Only one subtype at a time usually exists in humans, and usually only one variant. The reason may be that each new subtype provokes a general immune response to the flu virus, and that gives partial immunity against a variety of other variants of the flu, including older strains. So when the older strains finally cycle back into fresh populations, the door may already be closed. The 1976 swine flu was an H1N1 variant, which is why it caused an international panic. Nobody likes to get a flu shot. But in 1976, a record 40 million of us lined up to do just that. I was one of them, along with President Gerald Ford. Private David Lewis, a fresh recruit at Fort Dix, New Jersey, was the first to die of the flu. He collapsed in the middle of a 5-mile hike. Well, flu had been spreading through the barracks for weeks, but no one up to that point had died from it. Only 4 of the many flu victims at Fort Dix had that unknown swine flu virus, and of those 4, only Private Lewis died. But because the fatal flu turned out to be H1N1, it revived fears of the 1918 pandemic, and that was enough to push the red panic button. Once the military released the story about the Fort Dix outbreak, the press ran wild, exhuming all of the horror stories of the 1918 pandemic. And that publicity prompted the U.S. Health Service to call for a mass vaccination with a little tested vaccine. Many people died or experienced severe medical problems after getting their flu shots. Was it merely a coincidence, or was the vaccine actually dangerous? By May of 1980, over 3,917 lawsuits had been filed, seeking over $3.5 billion in damages. 300 people died of the flu vaccine, according to the lawsuits, but only Private Lewis is known to have died of the flu. Well, if nothing else, that 1976 swine flu scare prepared us for another epidemiological nightmare. A modern outbreak or a terrorist attack with weaponized flu would require a similar scheme of mass inoculation. In 1997, an explosive outbreak of avian flu broke out in Hong Kong. This was a new strain of bird flu called H5N1. And the sheer savagery of this new virus led to a renewed urgency to understand that doomsday flu. 1.5 million chickens were slaughtered to stop that disease in its tracks. 6 out of 18 infected people died, and that could have been the beginning of a serious new pandemic. But rapid quarantine and the destruction of every single chicken in Hong Kong stopped it in its tracks. H5N1 is currently the most dangerous type of flu in circulation. And many experts think that if this bird flu ever manages to fully cross over into humans, it would kill untold millions of people. The H5N1 mortality rate now stands at 59%. March 2005, H5N1 broke out in Vietnam, in Indonesia, and in North Korea, adding still more victims. Since 1997, 295 people have died from H5N1. The full designation is actually HPAI AH5N1, the HP standing for highly pathogenic. And this form of flu is epizootic, which means it occurs in non-human species. It's also panzootic, which means that it infects many different species of animals. Although it hasn't evolved yet to efficiently cross over to humans, all the danger signs are there. It's lethal, it's spreading very rapidly through avian populations, and it has already caused sporadic human infections. Flu expert Robert Webster says, "This virus, right from scratch, probably the worst influenza virus in terms of being highly pathogenic that I have ever seen or worked with. Not only is it frighteningly lethal to chickens, who can die within hours of exposure swollen and hemorrhaging, but it kills mammals from lab mice to tigers with similar efficiency." A multi-billion-dollar international effort is currently underway to study H5N1 and prepare for a possible future outbreak. Well, why do so many strains of flu continue to originate in Asia? The most likely explanation is the large number of people living in close proximity to domesticated pigs and birds, which is a recipe for a new pandemic. Between 1968 and 2004, China went from 5.2 million pigs to 508 million pigs, and from 12.3 million poultry to 13 billion poultry. So, was the 1918 flu an Asiatic flu? Some think it might have begun as an avian virus in China. And many agree that that killer flu, or a very close relative, caused some mild local epidemics in 1916 and 1917. We mentioned the likelihood of Kansas as a point of origin in humans, but a recent paper by John Oxford claims that it first erupted in a massive field hospital complex in Étaples in northwest France in the winter of 1915 and 16. Symptoms were very similar to those of the subsequent pandemic. Was the 1918 flu a swine flu or an avian flu? Taubenberger was originally certain that the 1918 flu virus came from American pigs, but his latest research demonstrated that in fact it was an avian flu. Flu expert Robert Webster claims that it was definitely swine flu, and probably circulating in mammals for some time before 1918. But Taubenberger remains unconvinced, pointing out that the swine flu was not described by veterinarians prior to 1918. Gavin Smith, in a 2009 paper in Nature, hypothesized that the virus was actually a blend of both avian flu and swine flu. Pigs can catch both human and avian flu, and that makes them a veritable viral blender. So the 1918 flu might have been part pig, part bird, and part human. H1N1 has become one of the most common causes of respiratory disease in pig farms in North America, hence that swine flu designation for H1N1, despite the fact that it may ultimately come from birds. The 2009 swine flu epidemic was an H1N1 subtype, like the 1918 flu, which is one reason why doctors overreacted so strongly to that outbreak. But initial analysis of the 2009 swine flu pandemic indicated a higher mortality rate for young adults, just like the 1918 flu, and once again caused by extreme cytokine storms. In 2004, a team from the University of Wisconsin at Madison took 2 genes from the 1918 flu virus, the ones that code for the H and the N spikes, and they stitched them into the genes of mice. They created special strains with both genes or with just the 1918 H or N genes. The spliced N gene, all by itself, proved to be relatively benign, nothing special. But that mutated H binding protein, whoa, that proved to be one of the primary factors that made the 1918 flu so incredibly virulent. That same team, in 2008, found a key set of 3 genes from the 1918 virus that allowed it to target cells in the lungs, rather than just the usual upper respiratory cells that flu viruses would ordinarily attack. In 2005, Taubenberger's team announced they had finally decoded the entire genome of the 1918 flu. They used the Army specimens, preserved in paraffin, and fragments recovered from Hulton's Lucy, and concluded that it was an avian virus that had found a new host in humans. Well, whether pig or bird or human, or a combination of all 3, if that 1918 flu does return, we may be prepared for it this time. Terence Tumpey's team, in 2006, spliced genes from the 1918 bug into a modern virus, a living virus. He then tested an experimental DNA vaccine that had been developed by the NIH and found it to be effective against the live reconstructed 1918 virus. Mice who were infected with the lab bug all died, but all of the 10 vaccinated mice survived. And so, we've seen mankind on both the winning side and the losing side in our age-old struggle with microbes. We conquered the germ of laziness, but we were decimated by the 1918 flu. And, as we'll learn in our next 4 lectures, there's a very good reason why we've managed to survive the evolutionary arms race so far. Our highly evolved immune system gives us a deadly weapon to use against our microscopic rivals.